Let me tell you a story about a guy who didn't study hard in math and he didn't pass his classes. The end. Okay, so number four. The flow during the month of May is shown for the Chetco River in Oregon in 2014. I don't know where that is. You could look it up. You should. I'm not going to look it up right now. But yeah, just look it up real quick. I'm sure you can because you're watching this video on the interweb. Okay, use regression and the graph of the data to find the best model for the data. Okay, so I'm going to go plug the data into my calculator, and I'm going to pause it. Okay, so we've got all this super cool data here, and now they don't tell us, hey, go find a linear model, go find a quadratic, a power, a logarithmic, and exponential. They don't tell us which kind. This is the way things really work in the world. You gather data and you say, all right, I need a model to represent the data. And I'm just curious what that did. And so, now that I got the data, let's figure out a model that works well. Okay. So in order to understand that a little more, the author gives us this cool little checklist. Okay, I'm going up. And so in this section, he says, all right, we got three main tests for determining a good model. And sometimes, it'd be like, well, it could go either way, it could be power or it could be quadratic, or something. But we have to come up with a single answer, because it's class. All right, so first of all, the eyeball test. Observing the fit of the graph, which with the ordered pairs in your graphing calculator. Okay, does it look like a good fit? All right, that's number one. All right, so let's take a look. So first of all, we need to graph the data. So I'm going to go y equals, clear out any old functions, and I'm going to go up to plot one and make sure it's turned on. Now it's turned on. You turn it on and off with the enter key. Okay. And then I could just go straight to the graph, but I probably won't see much. Okay, because the regular graph just goes -10 to 10 in both directions. Meanwhile, our data is, for the most part, quite a bit larger than 10. So that's not going to cut the mustard. Okay, so I'm going to go zoom, and then option 9, zoom stat. That'll zoom right in on all the data. Oh, okay. I see what we got here. And you can say, all right, what looks like it's going to fit well? Well, I mean, a quadratic might fit well. Okay. Or you could do a logarithmic. It just gets flatter and flatter and flatter. Or I mean, exponential. I mean, this could also be exponential. It could be power. It's definitely not linear. Linear is definitely not going to be the best fit because that's just a straight line. What about, I already mentioned quadratic, but let's think about it. What do we got here in this problem? I got to go find it again. So, well, it represents, okay, X is, day of the month. Okay. And the flow is going to be the Y value. All right. So, I mean, I'm no engineer, river engineer, but I mean, would it make sense for it to get lower, and then pop back up like a quadratic? I kind of doubt it. I mean, after all, there's only one more day in the month, and it still hasn't started popping up. So, I don't think quadratic is going to cut it. All right, it just doesn't make sense. So, and we already ruled out linear because it doesn't, not a straight line pattern. All right. Let's go back up to what the author had here. Okay. So, so the eyeball test. All right. So I'm thinking linear and quadratic are both out. But that still leaves 4 other choices. Or no, I'm sorry, 3 others: logarithmic, power, and exponential. Okay, so what about the R value test? This is definitely a good one. And there's no winging it associated with the R value test. So the R value test looks like this. first of all, as I've gone through these videos, um, and I've done different things like, hey, what about linear regression? And then we went down, we did it, and some of you had r and r squared numbers there, and I never did. Okay, well, it's time to get those. So I'm going to go to, what is it, mode? No, I'll just go second zero to the catalog, and then I want to go down to the D's. So I'll just hit this button here because it has the D over it. And I'm going to go down to diagnostic on. I'll hit enter to select it. I'll hit enter again to execute the command. So it says done. Now, when I go to do, one of these regression things, now the R's are going to pop up every time. And I shouldn't have to do the second zero and all that ever again. Okay. So let's take a look at what we got here. So for because the R value that tells you the R and the R squared, that tells you how closely this equation is going to be to those points on your scatter plot that we saw already. Okay. Now, the closer, now, as we go through this, you'll notice that they all use r squared, but some of them don't use r. So we're just going to use r squared, and that'll suffice, okay, because they all use it. R squared is always between 0 and 1, always, okay? It's a big, nasty formula. I think I showed it in some previous video. The closer that your r squared value is to 0, the worse that your equation fits the points. The closer your r squared value is to 1, the better your equation fits the points. Okay? So we want something close to 1. Now, if your r squared value is exactly 1, first of all, in the real world, that's kind of suspicious. It's like, whoa, how did I get an exact fit? That's very unusual. It can be close, but it's rarely going to be exact. Okay, so let's see what we got here. So our linear regression gave us an r squared value of 0.7544. I like going out 4 decimal places because then you don't have to worry about, them being the same. Okay, so what if I go do the quadratic regression? Let's see what we get there. Ooh, okay, that's quite a bit better. But then again, I mean, the data did have a curvy look to it, and quadratics are curvy. Okay, so we get 0.9318. Okay, that's a lot closer to 1. Clearly, that's a good fit. But based on our discussion earlier, I'm not going to go with quadratic because quadratic means that, the CFS is going to pop right back up, which I really, really doubt is going to be the case. Okay. And let's see. Let's go to power model. How do I do stat over? Power was what, like A or something? Okay. Ooh, that's higher. Okay, certainly. Let's see. So R squared is 0.9810. Okay. Nice. Okay. Now we're gonna go let's try exponential, which I think was 0. Yes. All right. And we get 0.9266. So a little lower than quadratic. Although exponential, when you graph an exponential function, it'll usually kind of come down here and get flat, and it stays pretty flat, like a logarithmic equation. That would be a decreasing exponential function. And so even though quadratic has a better r squared value than exponential, exponential is still better just because it makes more sense. Okay, because the CFS is not going to be popping up anytime soon. Okay, the cubic feet per second. In fact, you know what? Why don't we just cross that out and cross that out right now, because I've already disqualified. Okay, one more. Let's see, I gotta turn that on. Okay, so then I'll go stat over, and then and you could just type that. I can just hit the number 9 and do logarithmic regression, but I'm showing you. Okay. Alrighty. So this one has 0.8619. Okay, so I'm going to do an LN. I don't want to confuse it with the L up there. 0.8619. Okay. Alrighty. So clearly, out of these three that we still have that are in the running, power model is the best, and logarithmic regression is the worst. All right. So, all right. So we've got that. We have not finished making our decision, though. All right. The last one is common sense. You may know something about the relationship that would affect your choice. Common sense is something that is sorely lacking in the world. I think we can all agree, especially in places like, say, Washington, D.C. Okay. Anyway, so that is definitely something you want to think about. And I've been employing that as we go along. That's how I disqualified quadratic. Okay. So the eyeball test and the R value test, they're similar. There's a lot of similarity there. Okay. So let me show you a new cool trick, because we want to graph this. For the eyeball test, we want to see how it looks. Although the R squared values, give us a pretty darn good idea. All right. So in order to see how it looks, I'm going to need to type these equations in. Well, I don't want to type all that in. Okay, I'm not going to type in linear and quadratic. Again, I disqualified it for this problem. So what I'm going to do instead, I'm going to show you a new trick here. I'm going to go, okay, so for power model, I'm going to go down to the power there, and then I'm going to put my cursor right here. And I'm going to say, hey, calculator, I want to store the regression equation somewhere. I want to store it in, I'm going to go green, trace, and I'm going to pick Y1. So now when I hit calculate, it's going to store the equation in Y1. I still get the same equation, okay, and the same R squared value, okay, the 9810. But now if I go to Y equals, there it is. There's the equation. Cool. All right. And it's on my calculator, it's going to be blue. All right. If I hit graph right now, I can see it. And I can say, yeah, it follows the points really well. I mean, the R squared value is quite close to 1, so that's what I expect. Okay, now let's do exponential and logarithmic. For exponential, I'm going to go to exponential regression. I'm going to go to store regression equation and say alpha trace. But if I do Y1 now, the exponential equation will overwrite the power model. So I don't want to do that. I'm going to put it in Y2. Okay, and that one's going to be red, I think it is. Okay, so there's the red one, the exponential. And then I'm going to go do the logarithmic one, number 9, and I'll stick this one in Y3. And okay, and then there's the logarithmic equation. And then I can go to graph, and okay, so there's power, there's exponential, and there's logarithmic. Okay, yeah, and you can see just by looking at it that power is definitely fitting best on this problem. Again, the next one might very well be quadratic. Who knows? But yeah, it definitely fits better. I mean, it's fairly close to, it's pretty close to this one. The other two are a lot farther away. The power model just follows the pattern a lot better. So I'm going to go with power model as our function to represent this scenario. Okay. So yeah, the author takes you through it as well. It's good stuff to read. Good to listen to this video more than once. And the author is using the TI-84 calculator, which is really nice. Makes it a lot easier for you to tell what's going on in his explanation. Okay, so use regression and the graph of the data to find the best model. Okay. Okay, we did that. Oh, but I probably should write it down. Okay, so let me go. Okay, so we know it's the power model. So I'm going to go do power again. Okay, but this time I'm actually going to write down the function. I didn't do it before because I didn't know if I needed to. Okay, so let's see. All right, so it's going to be y equals 74,530 point, and I don't remember how many decimal places. Let's check it real quick. Doesn't say. I'll go one. Okay. These numbers are big enough that one decimal place is probably going to be plenty. Okay, so 0.4. And then it says multiply that by x raised to the negative 1.4 power. Okay, cool. So there's my model. Okay. So briefly defend the equation you chose. All right, I've been defending it all along. I've been explaining it all along, why I went with the power model. Okay. Part C, use your equation to predict the flow on June 9th. June 9th. Okay, well, this is May 10th, May 12th, blah, blah, blah. So June 9th, that's going to be, let's see, May has 31 days. And so 9 days after that in June is going to be day 40. Okay, so day 40 is going to be June 9th because day one is May 1st. Okay, cool. So I'm going to plug it in. So I'll go 74,000. There is a way to have the calculator do all this for you, but then I got to teach you how to use the table, and it's not that big of a deal. But we'll be totally fine with that. Okay. Okay, so on June 9th, we expect 426 cubic feet per second. All right. That's what we expect on day 40. So 40 days after May 1st. All right. Part D. My daughters are just going nuts over there. Yeah, I'm at home. Okay, so use your equation to predict the day the flow will hit 345. Okay, so now they're giving us a y value. And hey, shut up over there. All right. So yeah, they're not going to care. So so now they're giving us a y value. Okay. And so at this point, I have to know how to handle that for all 5 types of functions. How do I solve for x if they give me a y value, no matter what kind it is? Okay, this time it's power model. I'm not going to do 5 examples, one for each. I don't need to. All right, so the power model. So I'm going to say, all right, so 345, whoops, that's my y value. And that's 74,530.4 times x to the negative 1.4. Okay, you remember what to do? Oh, good, I'm glad. We divide both sides by 74,530.4. Okay, calculator out again. And it's going to be super cool. Okay, so I get 3,4,530.4. Okay, and that's going to give me about 0.0046. Yeah, James Bond's long lost friend. Okay. Okay, so we got that. Now, at this point, what do we do? Okay. If you remember from whenever we did power, I think it was chapter 3, we said, oh, I'll say log base 0.0046 of negative 1.4 equals x. So x is going to be, you know what? I think I'll just do that part. Well, no, I'll just do it on my calculator. Okay, so I go, what was it? Alpha window 5. I'm gonna just grab that unrounded number, the 0.0046, plug that in for the base, and then negative 1.4. And did I, oh, I did something off. What the heck? Okay. Go to, oh, I've got an error here. Okay, that is very peculiar. I don't know why I'm getting an error because I'm doing this wrong. This isn't what to do. Okay. That's for exponential, not logarithmic, or not power. Okay. I need to instead, sorry, raise that to the 1 over negative 1.4 power, and raise this guy here to the 1 over negative 1.4 power. Okay, so the powers there will cancel, and we'll be left with x equals. Okay, here we go. Okay, so I got that number raised to the 1 over negative 1.4. Okay, here we go. And that's going to be 46 and a half. So, and X stands for which day starting with May 1st. So day 46 and a half. So if we knock off the 31 days of May, that puts us at day 16 and a half in June. So halfway through the 16th of June is going to be our answer. Okay. And then that's that. Okay. And then find the slope between them, explain its meaning and context. We've done that. I'm not going to insult your intelligence. We've done that lots of times in previous videos. And anyway, but that is what you do. So figuring out which model to go with, that is the big part. Okay. Because all the other stuff you've done. Okay. So it's part A, which is kind of weird that the very first part is the new stuff, but that's what it is. So practice that, and and it takes practice. It takes some getting used to. And yeah. Anyway, that's all I got for today.